All right, let's see what we got. It's gonna be another medium today. Looks like jump game 9. You're given an integer array nums. From index I, you can jump to another index j under the following rules. Jump to index j, where j is after I, is allowed only if nums at j is less than nums I. So you can go to a later index if it's a smaller number. Okay, so it's like jumping downwards. Okay, and then jump before it if it's a bigger number. Sure. So it's like going, you can jump downwards if it goes right, upwards if it goes left. So it's kind of maintaining some sort of decreasing rightwards motion, kind of. For index I, find the maximum value in nums that can be reached by following any sequence of valid jumps during I for each index I. Return an array answer where answer I is the maximum value reachable starting it from index I. So 2 can jump to 1, so this should be 2. Oh, the number reachables. So 2. 1 can't jump. 1 can jump to 2. 3. Maybe I'm not getting this one right. If j is before I is okay from index I, if j is before I, only if j is bigger than nums I. Why is this one 3? Since nums of 2 is 3, the maximum value nums, no jump in value, no jump increases the value. Or return, I see, it's the maximum. Oops. I was thinking it was the return the number of spots it can jump to. Okay. So yeah, 2 can jump to itself, basically. 3 can't jump anywhere. 2 can't jump anything. Oh, 2 can jump to 1, 1 can jump to 3. Oh, wow. 3 is the maximum, 1 can jump to 3. Oh, wow. That is interesting. 2 to 1, 1 to 3. So 2 can't jump to 3 immediately. But 2 links to 1, 1 links to 3. It's almost like a graph. Like taking past the graph. Probably this is a pretty long constraint, I think. Yeah, 10 to the 5th. So it's almost certainly, I want to say linear. No, not almost certainly. It's linear or possibly sorted. Probably linear in terms of time complexity. So how would I do 2, 3, 1? So 3, and trace 3 to, you can make 3 once 3 is on the board, 1 can go back to 3. Wonder, 1 is the lowest value possible, right? Yeah. So 1 can't jump to anything lower than it later in it. So if this was something like 3, 4, 2, in theory, it could still be something like 101, and then everything becomes 100. Wonder if I should start with the largest. This feels like a monotonic stack deal. So let's see. If it's a bigger number, if it's a certain number, the only reason why it would, so if it's a certain number like 3, right? Or a certain number like 4, the only reason why it would jump forward is in order to jump backwards. Because if there was a big number before, like let's say 5 here, 4 can already jump to 5 using the second type of jump. So it already knows that 5 is kind of beat it. But it could jump forward to a lower number and then use that lower number to jump to a bigger number that's between it and that lower number. That's the only reason why I would jump forward. And if it was something like this, $100 would beat the 50. So like these two would be 100 as the maximum. But these things would not be able to jump to that because there's no lower thing after it. It's quite tricky. I wonder. How would I say that this one links to I guess? Maybe I do some sort of linkage. So maybe I do something like for every number, give me the lowest number after it. Does that work? The lowest number after it? No, I don't think that works. Because it could be something like this. So 5, the lowest number after it's 1. But I kind of want the second lowest number after it 2. Then 2 links up to 100. Each number, what do I want? I could do something like for every number, what is the biggest number before it? So it would go something like that. That's the biggest number before it. It or the biggest number before it. Then how do I link this 2 to 5 or 3 or 4? 3, 4, 1. 3, 4, 1. If I did a monotonic decreasing stack, it'd be like 5, 3, 5, 3, 4, 1, monotonic decreasing stack. When I push the 100, it should be, if I push the 100, it should pop everything from the stack. Maybe I need 2 stacks here. Kind of need to know that 1, this 1 can't be, so like in theory the answer here is going to be like 100, 100, 100, 1, 100, 100, 100, right? I think that'd be the answer. Say what? How'd this become 100? Oh wow, the 1 can go up to 3, or 4, or 5, and then jump down to 2, and then go up to the 100. So it's all linked. I guess I didn't recognize that. Oh wow. Okay, maybe that makes it that much simpler. Okay, so these are all linked. Like whatever the answer would be, then they'll get to the same spot. I could do a monotonic decreasing. So, 5, 3, 4, 1. They're all linked to this 5 at that point. And then maybe I need to have a monotonic increasing stack actually. So 5, 3, 4, 1, 100, 50. Maybe I need to maintain 2 stacks, monotonic increasing, monotonic decreasing. So it ends up being 5 and 100. And then the monotonic decreasing stack is 152. Does that make sense? Monotonic increasing, monotonic decreasing. So 3, 5, no, 3, 5, 3, 4, 1. Even that, once I have this 1 here, the 3 links up to the 5. 3, 5, 3, 4, 1. maybe I have maybe I actually have a queue. I'm thinking, let's say it's something like this, right? That being a start, I maintain some sort of queue that is increasing to start, decreasing to end. 2, 3, 5, like they can't jump up. But 4, 1. So 4, so 2, 3, 5. And then when I process the 4, I would add that to the stack or to the queue. Or maybe I don't. 4. Because 4 just links up to the 5 and doesn't really change anything with 2 and 3. And then when I process the 1, 1 does something here. I think the front stuff that is bigger than 1 needs to be removed. Because they all now link up to the 1. Like the 2 can jump to the 1, the 3 can jump to the 1, and then the 1 jump to the 5. So I have like a queue where I pop from the front if the front is bigger than the back side, and then I pop. Okay, so maybe it's just a monotonic increasing stack where I occasionally have to remove the front. So it's a monotonic increasing queue where the latest element needs to pop things up from the front of the queue. Yeah, maybe. Because if this was like, let's say, something like this, it would be 2, 3, 5. 4 doesn't affect anything. 100 would do what? 100 push on the queue. 100 would push on the queue. And then 50 doesn't do anything. 3 would remove this 2. Because the 2 would link to the 3. And then this would be the ending. So somehow this is going to be like 3, 5, 100. And there'd be another 100 here, something like that. No. Two, 3 here. What happens at this point? 3 is bigger than the 2. So somehow the 2 needs to match up to the 100. 2 needs to match up to the 100. Then if there was, could it possibly be that there's multiple layers to it? Let's say there was, this is like, let's say these were all increased by a factor of 10. So, and let's say there was a 5 here, and then eventually it became 1001. At that point, what would happen? No, that would remove everything. Everything jumps down to the 1, right? So it can't be. So the front stuff that's removed would take on the highest. It has to take on the highest in the array. Pretty sure. Okay, so I'm gonna try something I've never tried before: monotonic queue. Monotonic increasing queue. So say the double-ended queue is going to be empty, and is the length of nums for every value in range, or I think I guess, do I need to know the indexing? I don't think I need to know the indexing. So for every value in nums, might as well just use some indexing. So the k is going to be index. The value is nums at k. Maybe I should just start with the first one already on the stack. I think I want a tuple here. I'm pretty sure I need a tuple that keeps track of the count of the things that have been popped. So I think it should be nums at 0, maybe the index 0 and 1. And then this is going to be index from 1 onwards, so skipping the first element. So if it was like 20, and then it went to 30, 30 would just push onto it because it's increasing. So if it's bigger than or equal to, I want to say, or if it's just bigger than, if it's equal to, then I'll also want to push it onto it. Or if it's smaller, then I will combine. Yeah, if it's bigger, then I want to push onto it. If it's smaller, then I want to do something else. Okay. If the value is bigger than the last element of the deck and the actual value there, then deck appends the tuple that is this value, this index, and 1. Else if it's smaller or equal value, pop front. And so I need to remove anything that, so if it's like a smaller value like this 30, needs, or let's say there's a 10 here, if this is a 10, then it needs to remove anything in the front that is smaller than it. So while dec at 0, the value of it is less than, is greater than this value. I can only jump downwards, I can't jump equally. So if it's greater than, then dec.pop left. That's it. Okay, and then update the last. If it's bigger, then push onto it. If it's smaller, then I need to combine like this count of the number of things that this thing swallows. Do I need that actually? Can I just track it using the indices? Maybe I can track it using just indices. Right, if I know when I push the 100, then every index from that point on to the next element would be 100. If there wasn't any screw ups. Yeah. Right. I'm doing this wrong. Almost certainly doing this wrong. Yeah, because like what happens if this is 10 and there's like 1,000 or 10,000 here, like the 20 and 30 gets removed, but at that point it would only be able to jump to this 10, so then it would jump to this 100. So then the 20 and 30 has to be linked to 100 and not the 10,000. So I can't assume that just jumps up to the biggest one here. Hmm. 20, 30. Wow. Wow, 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 wow. 20, 30, 50. So 50, 100, 30, 100, then 50, 30. 50 would link to the 30. So it would all be 100 at that point. Yeah. Suckering succotash. 100. 10,000, 10,000, 10,200, and that doesn't link up to anything. I wonder if I can do some sort of connected. I wonder if I can do some sort of connected graph here. I think that'd be too complicated. Or too slow, one or the other. Index links with this index. This index could link this thing if this was low enough, if it's like 2 instead of 200. We need to somehow link up with these things. Otherwise, if it was 200, then what would the look of the stack be? Stack would look like 100, 10,000. And that's it. And then somehow these would all need to be 100. And then these would be 10,000 in the final array. If I have a monotonic increasing stack, 20, 30, 50, 40 pops, 100, 50 pops, 40 pops, 50, yeah, 50 pops, 30 actually, yeah, 30 actually does pop this thing, huh? Because 50 jumps down to 30 and then jumps up to 100, so okay, I'm really fucking this up. There's no way what I'm thinking about is gonna work. Because the 30 sees the front of the queue. Front of the queue is 20, which is not bigger than 30, so it doesn't actually pop at all. Smaller value, pop from front, smaller than, oops. And this was the original intent, bigger than it. So I can't even do that part. Why would I even need? Yeah, I need the 20, 30 because that's things that cannot jump. Right. Because if this 50 is here, or let's say this was a 45 here, then the 40 links to the 50. The 50 then links to the 45, which then links to the 100. But the 20 and 30 stays where they are. I can't do any jumps. So I wonder. I wonder. Jump downwards smaller than it. Jump downwards smaller than it. Jump backwards bigger than it. Jump backwards bigger than it is going to be strictly, it can be strictly the monotonic part of the array should probably handle that. So you should never really have to worry about that. If you're keeping a monotonic increasing. So if you keep monotonic increasing 100,000 or 10,000, so in theory, like 40 jumps to 50, 45, 30, 10 jumps to the 100, 200 jumps to 10,000. That's your baseline. That'll be like jumping to the last biggest thing. But that doesn't count into jumping forwards. Maybe I need to keep track of two things, the biggest and the smallest. So maybe this is 50, 40. Maybe this is 110. Maybe this is 10,200. So that when I somehow adds the linkage. So the biggest thing here, 100, if it's smaller than this thing, this 200, then it gets combined. Does that make sense? So because 100 can't jump down to 200, then it remains distinct. So the 100 and the 1,200 can't do anything. But then, and then that pops. And then the 50, 40, because the biggest thing here, 50, is bigger than the lowest thing here, which is 10, then it combines. But if this was something, let's say 45, then the 20 and 30 never combine with the 100. So these are like 30, 30, and 20, 20. So I do a monotonic increasing stack that also has the lower bound within that interval. Does that work? Also has the lower bound within that interval. Is there any way for this to like have some sort of weird some tuple here jumps to here but not handle the things beside it? What if it was something like, what if there was a 20 there? I guess the 20 is still part of this interval and this really doesn't affect the fact that the lowest is 10. Okay, okay. This is not precise. This should be like that. Okay. So I'll have a stack monotonic increasing. I guess this is now a stack. I don't need a queue. I guess I just might as well just redo this shit. N is equal length of nums, and then stack is equal to, let's say, nums at 0, nums at 0. Do I need to keep an index? Probably indexes. Probably the index is helpful. And this will be tuples of kind of high value, low value, and starting index. Okay, so for every index in range 1 to n, if, say, the value equals nums of k, if the value is bigger than the previous, so stack less element to stack the high value of it, then stack appends this value as the high, this value as the low, and the index. Else, this needs to combine with the previous stuff. So each tuple is an interval of kind of connected high-low values. So I think prev high if this value is smaller than the previous low value. Then stack pops. No. Prev high and index is the last element of the stack, or I'll just call it stack pop. And then stack appends the previous high. This is your new low value and the same index. Okay. Okay, so then that should finish out everything in the nums array. Then I just need to get the answer array. Let's say answer is equal to 0 times n, and then I'll just parse it backwards. So do I need to parse the stack first? Like combining stuff? Yeah. So if 100 is bigger, so I need to combine this stuff. How would I parse it while combining it? So I do 1,000 onwards. I guess I would only parse this thing if I couldn't combine it with the previous stuff. So I could try to combine this thing. So like if the previous thing here was, let's say 210, or no, let's say this was 310. Then in theory this thing would combine and this would become maybe 10,010, because 300 here would jump to the 200 here, and the 10 here would make this linkable. Yeah, so we need to, like, I would need to combine these two, link them up. So I guess it should probably just be while stack. If stack at -1, or if there's two elements in the stack, and stack at -1 if the low value if there's more than one, if the low value of the recent one, which is going to be index 1, if the low value is smaller than stack of the second previous one, its high value. No, so it's lower than the previous high value. Then I need to combine. So it's going to be a pretty big combination. So this is going to be, current high, current low. I don't really care for the index at this point, I don't think. And then what I really want is this index here, and this low, previous high, previous low, and this index. And then I need to do stack appends. Maybe I need to do this in a while loop. Sorry, in a while loop. Stack appends, current high, the min of the current low and the previous low, and the previous index. I think I want to continue here. This is combine intervals. Yeah, so if it's combinable, if there's two and they're combinable, then combine them. Otherwise I need to actually push this onto the, need to kind of, I'll say this is print interval to answer array. So for, I guess I probably should just do current high, current low, return the index for every shit. I think I'm going to do last index is n for k in range from this index to the last index. Then the answer array at k is equal to the current high. And then I think the last index is equal to index. Okay. This seems really bad in terms of should this while loop just be while stack is greater than 1? While the length of stack is greater than 1. This logic seems pretty bad. Okay. So I don't think I need to continue in this case. So if there's 2 elements in the stack, then I try to combine them if possible. If they can't be combined, then I print them out. And then I need to go on to the next one. And at this point, there should just be one thing in the stack, maybe. There should just be one thing in the stack, and I just do that one last thing. So, yeah, so this should just be for k in range. Always has to be from 0 onwards, right? 0 onto the last index. K in range to last index. Answer at k equals whatever is the first thing in the stack. Stack, whatever value that is. Maybe. Probably not. Okay. Well, interesting. So case 2 does not work. 3, 1. I don't see why I didn't combine that logically in my head anyways. So there should be 2 elements in the stack, right? Yeah, 2 elements in the stack. Yeah, so I don't know why I didn't combine. Wait, why is this 1? Or why isn't this 1 actually? If the value is bigger, if the value is smaller. If the value is smaller. Now if the value is bigger, add. If the value is smaller, if the value, oh, this should be -1. This should be just 1. Whoops. Okay. Okay, so logically that works. All right, cool beans. Okay. Okay, monotonic increasing stack. Stack is low, high intervals. Or ranges, I guess. Where we index if the value is bigger than if it's bigger than the previous value, or if it's bigger than this is create new interval if new high, and then else combine it into previous interval, modify, else combine into previous, basically modify low if lower, modify, or I guess update if lower than low interval. Current being the last interval of this on the stack. If I can't really do a straight modification of the tuple itself, so I have to pop it. Okay, so that's the create the stack. And then this is the processing. Process stack backwards, printing intervals to answer array. So while stack is more than 2, then combine intervals if previous high is greater than previous or current low. Previous and current being like the last two intervals, previous interval and the current interval, i.e. jumpable. So if the previous high can jump to the current interval slow, then it can basically connect. And when you combine it, then you basically combine the minimums and you make the index into whatever the previous index is. I guess I should call this previous index, just to be clear. Because they're just going to kind of gobble each other up. Else, otherwise, if they can't combine the two latest intervals, then just print it out to the stack and then pop the interval. And then there's one last interval on the stack. Okay. $20, $20, $30, $30, $50, $40, $100. Oh, this should be $100, $45. Or actually, let's say the example is here is like that. Something like that. Okay. Okay, so summary here is, I'll say this is kind of example. So summary, create a modified kind of monotonic stack with tuples that have kind of low or high, low, and index. I guess here, if I kept track of indices, it's like 0 is the first index for the 20, 1 for the first index of the 30, 2 for the index of the 50, 3, 4 for the index of the 10, or 100, and 4, 5, 6, 7, 8. Create modified tuples that have monotonic increasing stack that have high, low index. So that's just pretty straightforward. Update the low value for any new values on the stack that gets gobbled up by the current high. So if I, for instance, if I have 50 on a monotonic increasing stack, the 40 would just not be pushed onto the stack because it's not increasing, but then the 40 would be tracked into the tuple as the low of that interval. So 50, 40 is like this interval high, low value. Same thing with the 100, 45 gets kind of gobbled into it as the low. And then when 10 comes in, the 10 becomes the low of the interval. And then when the 20 comes in, the 20 doesn't modify the low, but so the interval is still like 110 for where the interval starts at index 4, has a high 100, has a low of 10. And then obviously that's that. Once that stack is created, process it to create the answer array. In particular, when processing the last two intervals, because you have to process the intervals backwards, so you're like processing these two intervals, for instance, consider combine those intervals if the kind of previous high interval is bigger than the current low interval, since they can be connected through some jump. If the last two intervals cannot be combined, okay, this obviously do this in a loop. If the last two intervals cannot be combined, print out the last interval and pop that interval from the stack. So as an example here, if this was the last two intervals, because 1,000 has a low, because this interval has a low of 200 and this interval has a high of 100, that means they can't be combined. The 100 can't jump down to 200. So I would print out this thing, print out from index 8 the high value of 1,000 to basically the kind of last index of the last printed interval, which is going to be up to index n. But if, for instance, this is, let's say there was additional 1, which modified this interval's minimum to 1, then therefore the 100 can jump down to the 1, and I'd actually combine these two. So I'd make this into like a single interval that it was 10,000 as the high, 1 as the low, and 4 is the starting index, because yeah, the index, these intervals combine. If this was something like, let's say this is 20. So this interval has low of 20. This means the 100 can still jump to the 20, but it would still take on the low of this interval. So it'd be the low of 10 here. And then you just keep on doing that process of combining intervals or printing out intervals until you get your final kind of answer array. And time complexities can be O of n, since it requires 2 passes over the indices. 1 pass to create the stack, 1 pass to process the stack. The stack can only have n elements, at most n elements, and all the indices that traverses is going to be at most once, where it traverses each index at most once and does constant work. Space complexities can be O of n to maintain stack of up to n tuples. All right, cool.